Great, welcome back to grade 7 math. We are now on lesson 3.5, which is on frequency tables and stem and leaf plots. This is a pretty simple lesson. It's a matter of just looking at data and organizing the data. You don't have to take everything down. What you could just do is look at the results, and then what I want you to do is just copy down the frequency table when we get to it. So the situation is that we're at the track and field meet, and we have several students that are doing standing long jumps, so which means you are standing and you are jumping from a standing position, and then they measured these numbers. Now we're going to assume that these numbers are in centimeters. It doesn't tell us, but we can just guess that those are in centimeters. So given these numbers, we can organize them in a way and put them in order so that we can count to see how many, what was the shortest distance, what was the longest distance, and how many fit within each category. So a frequency table is a count of each item organized by categories of intervals of the same size. This is really important, is that when we choose our categories or when we choose our intervals, that they're the same size. Normally, multiples of 5 or 10 are the easiest, just because it's easiest to skip count by those numbers, and it's easier for the eye or for someone who's reading it to be able to look at the data more neatly. So let's look at the highest and lowest data points and look for a suitable interval. So if we scan the numbers, the lowest data point, or the smallest, appears to be 172 is the lowest. So that's our lowest, and our highest number is 229, I think. So given this, we're going to look at some intervals. Normally, something ending in a 5 or a 0 is really is much easier. Oh, I have a 230 actually, so let's make that 230. So if we look at our intervals, so let's start with, we can create our intervals 170 to 179. And then we have 180 to 189, 190 to 199, 200 to 209, 210 to 219, 220 to 229, and then we have a 230 to 239. Now this is just one option. There are other options as well. If I wanted to, I could have started at 171 and go to 180. 181 to 190, etc., etc., and the last interval would have been 221 to 230. If I wanted to, I could use intervals of 5. Uh, the drawback of using smaller intervals is that my data will be kind of spread out in different categories or different bars, more spread out than if I use smaller number of intervals. The good number of intervals is about 4 to 10 intervals in total. That's what we want. That's a good number of comparison. If I have much more than that, so for example, if I were to use intervals of 5, then I would have double the amount of intervals. I'd have 14 intervals. That would be okay if I had a lot of data. But the data that we're going to be given in grade 7 won't be enough to support 14 intervals. So having between 4 intervals is the best. So take down this information, and now what I'd like you to do is create a frequency table with these results. So I'm going to choose my interval, and in this case this will be in centimeters. Then I'll have my tally, and then I'll have my frequency. So let's start with intervals, noticing that I don't really like this interval of 230 to 239 because it only will include one data point in there. I'll opt to use this one instead, these intervals. So 171 to 180, 181 to 190, 191 to 200. Notice that as I'm going along that no numbers will be left out in this example. The only numbers that might be left out are any decimal numbers that fall in between 210 and 211, for example. But in this case, because there are no decimal numbers, I don't have to worry about that. So in this case, I have 6 intervals. I could have more. Because it fits my rule of between 4 and 10 intervals, then I should be okay with my actual results in the end. So what we do now is we go along our list and we tally up all of the numbers. So 187 falls under this category. It's interval. It's easier to just cross them out because then at least I know that I've used it. And my total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 3. I have 12 times 3 is 36. So I have a total of 36 possible answers. So what I'm going to do then is, let me just erase some of this. So what I want you to do is pause the video, and I want you to continue the rest of this interval table on your own, and then you can skip ahead to the end of the video and see if you're correct. If you chose different intervals from the ones I chose, then you may end up with a slightly different result, and that's okay. It's okay to have a different result, provided that the answers are going to be this. That it will still add up to 36. So I have to have a total of 36 data points that I'm going to be marking in my frequency table. So if we continue on, 205 is here, 221 is here, 186, 185, 212, 222, 215, 198, 200, 205, 230, 207, 193, 186, 172, 208, 223, 175, 206, 215, 227, 228, 218, 188, 173, 196, 202, 221, 214, 220, 229, 189, 193, 212, 212. Great, so once now I've found all the tallies of all of them, I can just convert these to frequencies. So a true frequency table has numbers or counts of that. So now I have my intervals and I have my frequencies. These are the ones that are really important. Make sure that your units are there in your title as well. Just as a check, let's just find our total number of data points. So I have 3 plus 7 is 10, and I have 6 plus 5 is 11. 11 plus, so I have 10, 11, and then this is 15, and that makes a total of 36 data points. So because I have a total of 36, I know that at least my count is correct. I could go back and check all of my answers to make sure that the numbers are correct as well, but this is basically a frequency table. So hopefully you understood this lesson, and we'll